Hello everyone. So this is Senthil Kumar, Assistant Professor from Mechanical Engineering, Kesha College of Engineering. So in this session we are going to discuss about the concept of black body radiations. In this class we are going to give some short notes about the black body radiations. I think it is very useful for all of us. So before that, what is black body? So black body is nothing but is an ideal body that absorbs all the incident radiation falling on the surfaces, and it is also called it is a perfect absorber and perfect emitter. It will absorb 100% radiations and it will emit 100% radiation. So there is a special characteristics of black body radiations. Now we will see the concept of behind the black body radiations. So when the black body is heated, it emits the thermal radiations with depending on the temperatures. So this emitter radiation is called as black body radiation. The radiation emitted by a black body is maximum compared to real surfaces at the same temperatures. Okay, the radiation emitted by the black body is maximum when compared with the real surfaces for the same temperature limits. So this diagram shows that the black color diagram shows that consider this is a black body where when the incident radiation falls on this black body, it absorbs 100% all the incident radiations and it will absorb and it will emit all the radiations. So this is a special characteristics of the black body. So more than that, a black body absorbs 100% incident radiations. Yes, I already informed. It reflects no radiations. It does not reflect any radiations, and it emits maximum radiation for the given temperatures. Okay. So before that, before studying that, a law behind the black body radiation is called as Stephen Boltzmann's law. So this law states that EB is equal to sigma into T power 4, or EB is directly proportional to the sigma T power 4. So EB is nothing but the emissive power of a black body, and the temperature is nothing is called as absolute temperature. So we can define the total emissive power of a black body is directly proportional to the fourth power of the absolute temperature. So this is the Stephen Boltzmann law, which is behind the concept of black body. So now the value of Stephen Boltzmann constant sigma is 5.67 in 10 to the power of minus 8 in watts per meter square Kelvin power 4. So now we are going to see some practical approximation of a black body. Consider a body with a small hole or cavity. A cavity with a small hole acts as a black body because radiation entering into the hole undergoes a multiple reflections and almost completely absorbed. So consider this is a cavity. So when the incident radiation falls on this hole, and the radiation is reflected multiple times inside the surfaces. So this projection is called as conical projections, and the surface is coated with black surfaces. So this is one of the best practical approximation of the black body radiation. So here it will give us radiation enters the cavity through a small hole, and the inside the cavity the radiation undergoes a multiple reflections. Most radiation is absorbed by the walls. Radiation emerging from the hole represents the black body radiations. So with this, thank you very much for patient listening.